Mesh analysis.
So this one was one that I wrote the year that I was doing this, and I had a broken right arm, but it was right at finals, and so I had to do my SI because I couldn't leave people hanging, and so that's why this is so messy looking. All right, so we're going to use mesh analysis to determine I in the circuit below. So when we do mesh analysis, now this was something that somebody was asking earlier. I in this picture is not going to be either of the currents in our meshes, because we're going to draw I1 like that and I2 like that. And I is a combination of I1 and I2, because both I1 and I2 go through that middle branch.
Wait. But where's I?
I was in the problem. I was given.
Oh, I see what you're saying. I1, this is I2. Okay,
And when we get to the end, we're going to say I equals I1 minus I2.
makes sense.
Okay, so let's write our mesh equation for the first mesh. So with a mesh equation, as you're going around, if you come to a voltage source, if you're going into the minus side, you put minus. If you're going into the plus side, you put plus, and just the number. And when you get to a resistor, you put the resistance times the current. So we'll start with this voltage source. We're going to do I1 first. We come in to the negative side, so that's negative 12. And then we get to a resistor plus 4I1. Yep.
32? Yeah.
That's a 2 ohm, yeah, plus 2I1 equals 0.
And then for the second one, for I2 would be, so it's coming into the
Mm-hmm.
plus 4.
Nope, minus 4.
Minus 4?
Mm-hmm.
Because of acid. Minus 4 plus, is that a 5?
Oh, okay, so it's important, you see how we drew it going this way?
Mm-hmm.
So we're going around this way.
So
I think that's why you said plus, is you were going the other way.
Mm-hmm.
So I always make sure that I make both my currents going clockwise, or both going, well, I always do both clockwise. But, and so the next one to do is not the 5 ohm, but the 3 ohm.
3 ohm.
Uh-huh.
So wherever the current goes in, it determines the value of my voltage, basically the sign of my voltage.
Yes.
Okay.
So what's the 3 going to be?
Oh, 3I2. 3I2 minus I1.
Yep. And then it's 5. 5I2.
Which equals 0. And then you can move the 4 and 12 over.
Yep.
4, 12, that's and from there, system of equations. Well, actually, it should be the 3 first. Boom, boom. 3I2 minus 3I1 plus 5I2. And this is going to be 4I1 plus 3I1 plus minus 3I2 plus 2I1. So combine all my like terms. I'm going to get 9I1 minus 3I2, which equals 12.
Right. And then you can divide, if you get the 9I1 minus 3I2 equals 12, you can divide that entire equation through by 3.
Yeah, sweet. Minus 3I1 equals. You got a 4. You take 3 out here, this is going to equal that. 3I1 minus I2 equals 4.
Right.
So this puts you negative 3I1 minus plus 8. Equals 4.
And then this one's all set up for us to do, just elimination. So add those together,
2 equals 8 over 7. So I2 equals 8 over 7.
which turns out to be 1.14. And I1. So now we have to do 3I1 minus I2 equals 4. So I'm using that equation. 3I1 minus 1.14 equals 4. 3I1 equals 5.14. I1 equals 1.71 amps.
Oh, that's easy. And then I1 is just gonna, so you said it's 3.1? 1.74? 1.714?
Just 1.71, I think.
1.71.
Amps.
Then you just do 1.71 minus 1.14, which is basically equivalent to I equals 2.8.
Wait, no, it wasn't minus because I2 was positive.
Oh, sorry.
So it's just 1.71 minus 1.71 minus 1.14,
I wrote my sign wrong.
which is 0.57 amps.